Oh, what's the time? Is it time? Is it time? Yes. It is. Cool. It's like that line from Marathon Man. Is it safe? Is it safe? Okay. So thanks for turning up. Testing as an equal first-class citizen to coding. I'll explain what I mean by that in more detail. A little bit about me. Some people, a lot of people will recognize me, used to be self-employed, whatever title you like, for 22 years. And just recently, I've jumped ship and I've done something I never thought I'd do. I've gone back to being a permanent member of staff at a startup that my friend Mike Long put together more than two and a bit years ago now. As the old joke, he made me an offer that my wife couldn't refuse. It is a startup, very early days, the usual startup complexity and churn, but we are hiring. And I know every time you see someone standing up here doing a presentation, they say they're hiring even if they're not hiring, but we are hiring, and we are. Based in Oslo, mostly, but I work remotely from home all the time. I've got a couple of other people working in Sweden, so we're the usual multicultural organization, as most people are these days. Now, throughout the talk, I'm going to sprinkle in the odd slide where I ask you a question, and I'm going to give you a heads up that quite a lot of the time, not all the time, but quite a lot of the time, this is the answer, all right? So let's practice. What I'd like to say is equal rights for tests. After 3, 1, 2, 3. Equal rights for tests. That's often going to be the answer, okay? Now, before we start, I'd just like to put a few words up about a personal pet peeve of mine. Particularly I see it on Twitter, and that's when young people, shall we say, make very definite assertions. And the more I see it, the more it peeves me. It seems for me to be kind of the opposite of the agile mindset, which is more humble, if you like. It's more that this is what I've tried. It's worked for me. It might work for you, but it might not, because your circumstances might be different. So whether it's just getting older or not, I don't know. But I see this more often, probably because I just notice it more often. And I'm conscious I don't want to do it myself. It's very easy to do even when you're speaking and when you're writing slides. So if I do it, I'd appreciate you telling me so that I can stop doing it literally as we're going through.
Your assertion contains a never.
And if you see it in the slides, please don't take it as assertive as it might otherwise be taken. Everything is merely a suggestion. But to come back to Dom's point, it's deliberate that the word never... Is there a clicker on this thing? I think there is. Yes, the word never here is part of the same, it's kind of a recursive rule, right? So the question is, do you believe this rule or not? Because if you do, you don't, and if you don't, you do, right? What's the rule really saying? Close, but no cigar this time. Think for yourself. That's what it's really saying. Think for yourself. I call this the Bill Bailey Law. It's a law I made up. I'm sure other people have made it up as well. If you want to know why it's called the Bill Bailey Law, ask me in the bar later on. So with that, we will start. And I'd like to talk about blood sugar. So if you eat a Mars bar, say, as I know Seb is prone to do often, just kidding. Then initially your blood sugar spikes and it goes up, but there are mechanisms inside the body, the mammalian body, that detect this and bring it back into some form of regulation fairly quickly, pretty damn quickly actually, and to quite fine tolerances of regulation. Unless, of course, you've got diabetes or something like that, which is more and more common these days. So how does this happen? How does that actually happen in the body? Well, if you eat a sugary substance, such as a Mars bar, then Some cells in the pancreas, whose name I forget, detect the increase. They sense that increase, and that's their trigger to secrete more insulin into the bloodstream. The liver and muscles detect that increase in insulin, and that's their trigger to pull the glucose out of the bloodstream and put it into the stored form. They change its form and store it, and that's called glycogen. So it's not important that it's called glycogen. The important point is that you've got less glucose because you've pulled it out of the bloodstream. And so that has the desired effect of reducing the amount of glucose in your bloodstream, and so you don't get hypoglycemia and die. But if this top loop happens unchecked, what would happen? It would just go down and down and down and down, and you wouldn't die from too much sugar in the blood. You would die from not enough. That doesn't happen either, because there are other cells in the pancreas whose name I also forget. When they detect this decrease, they secrete a different molecule called glucagon, and again, the liver and the muscles detect this, and that's their trigger to reverse this process that we just talked about a moment ago, and the glycogen gets put back into the bloodstream as glucose, which has the, again, desired effect of raising the amount of glucose. And so we have these two processes working in opposition to each other. And I find that deeply beautiful and deeply paradoxical. And this is just one example in living systems. Living systems just have this everywhere. It's been known about for a long, long time. If you search on the internet, you might come across a law called Le Chatelet's law, French gentleman. Often the pictures you'll see of him are in black and white because it's been known, this has been known for over 100 years. But it's also called the equilibrium law, which I paraphrase like this. Stable systems tend to oppose their own proper function. And I must be honest and say that when I was younger, I really didn't understand this. And looking back, I think the reason possibly was because there was these words that I've italicized, oppose and proper. Why would you oppose your own function if that function is the proper function? I didn't get it. And the reason I do get it now is in no small part thanks to a conversation I had with Hubert Matthews many years ago, where he enlightened me. There's some moments you just remember really clearly in your life, aren't you? A light bulb goes on, and it's just such a big light bulb, and that was one of those moments. And so now I feel I do understand it a bit better, because we've got all this tremendous activity, which you can't see in the cell, obviously, from the surface. All of this tremendous activity, all this activity and here, all this activity, all this tremendous activity going on and going on and going on, activity, and all this activity going on, all these two systems fighting against each other, right? Fighting against each other, fighting. Why? Why all this activity? No. To keep something else the same. That's the paradox. Activity, tremendous amount of activity. Why? To keep something else the same. So that's part of the paradox and the beauty that I allude to when I say this. And I'd like to point out that this is what you find in living systems, and it's the most robust thing there possibly is, known to man, I would say. Yeah, life has been on this planet, as far as we can tell, from 4 and something billion years. And we're here. We survive as a species and more species. Even though there's all this tremendous change in the environment, we survive. Or to put it another way, every single one of us in this room is the result of an unbroken chain of survivors that has lasted over 4 billion years. Which, if you think about it, just blows your mind, doesn't it? Robust. It's really robust. And in the 70s, going even possibly a bit further back than that, but in the 70s in particular, people who were influential in the systems thinking movement said that if you really want to start to have a really good, strong understanding of how you can think about this idea of change and activity, change and constancy, let's say, one of the things you might benefit from studying is natural systems, such as the glucose cycle that we just saw in mammals, yeah? And they were absolutely right. People like Stafford Beer, they were absolutely right. And this is my grandson, who's now 6 months old. And I put that up there just to remind myself how fantastic it is to be a granddad, but also, again, to emphasize this point about how unbelievably unlikely it is that we're here, but we are here. And it's so robust, this system, that has naturally evolved. Maybe we can learn something from it. Now, to push on this idea a bit further, and again, try and give you some insights into the way I develop my learning, my understanding, if you like, is that not only can you think about this idea of those two systems we saw in the glucose cycle opposing each other, you can think about that general idea of things in opposition to each other for basically anything. If you want to understand something, it's often quite a good idea to at least consider the possibility of comparing it against something else, possibly its opposite or something, yeah? So if we start to think about the idea of that dynamic system that we just described, yeah? We could also think about it statically. And maybe it's just me again, but my, shall I say, my natural tendency tended to be, I think, to think about things statically. In other words, lots of words can be nouns or verbs, which we'll come to in a minute, but I tended to think of them as nouns. And I probably still do, and I have to force myself to try and think of them as verbs as well. So to give you just a little example to hint at this, as we start looking at this in more detail, the background picture here is some kind of bird of prey, I'm not quite sure which one it is, having a rabbit, something there that it's captured for a meal. And fairly obviously, this hawk, let's say it's a hawk, and hawks in general, regulate the number of rabbits because there's a predator-prey relationship there. That's obvious. But that's the static view. For me, at least, that was the static view. Because now I look at it and I think also, well, the rabbits return the favor. Yeah, they regulate each other. Which is obvious when you see it, but when I was younger, I didn't see it. But that's a much more dynamic way of thinking about it, for me at least, yeah? Now, I find this endlessly fascinating. So I just pulled, I don't know why, but this quote popped into my head when I was putting these slides together. Ilya Prigogine, a Nobel laureate, as it says in very small letters at the bottom, wrote this book. And there's a quote in there that I've picked out because it spoke to me again. There is a necessary trade-off between certainty at a given time for continuity through time. And again, what he's talking about there, as I read it, is for example, the trade-off for natural systems. Because if you think about evolution in general, there's change going on which you're not in control of. So we could imagine a mechanism of evolution where the DNA replication is perfect. That would turn out to be quite a bad strategy. Yeah? The fact that there is some error in the replication is actually really, really important in the whole system dynamics of how this evolution works, not just at the small level of time, but in the eons of time over billions and billions of years. And the number of errors that occurs when DNA replicates is also itself subject to this same law. Because if you have too few mutations, that's not so good. But if you have too many, that's not so good either. Yeah? So again, those two are kind of in opposition to each other at a meta level. Once you start to see this, at least once I start to see this, I see it everywhere. So as Charles Darwin might have said, but as far as I know he didn't, evolution is always co-evolution. Things are always evolving in opposition to each other in a dynamic relationship with tremendous complexity, which we're only vaguely starting to grasp at in terms of the whole system across the whole biosphere, for example. And to pull out another quote from another of my favorite books by Bradford Keeney, who was a disciple of Gregory Bateson, again, coming back to the 70s systems thinking movement. All change can be understood as the effort to maintain some constancy, and all constancy as maintained through change. So again, a deep truth expressed also in a duality, which again is kind of meta. And this speaks to me, really speaks to me. It makes me think, for example, that if I'm looking at a system and something is staying the same, then there's probably stuff going on to keep it the same. By itself, in this crazy world we live in, things don't usually, all things being equal, stay the same. Rocks basically stay as rocks. Inert, non-living things basically always stay the same. Not quite true, obviously. Again, over billions and billions of years, stuff happens. But the rate of change for living systems is very, very different. So, like I say, if you see something that's staying the same, that's interesting. Maybe if you look in and you poke, you'll find there's all kinds of invisible things which you can only see if you really start to peek, that's keeping it the same, just like we talked about the blood glucose level and the two cycles in opposition to each other. Or, to put it another way, if you want to try and gain an understanding of change, maybe it would be a good idea to get an understanding of constancy, and vice versa. Because again, these things are in opposition to each other. There's always a duality, quote, always, right? So to put it in another way, we can think of stability and activity as always being the thing that creates the roof of the next one. Yeah, which is not expressed very well. Let me try again. If you want something to be active, to change a lot, it's hard for that thing to change a lot when the thing that it rests on itself is itself changing a lot. And so this is not what tends to happen in natural systems. If something is changing a lot, it has to, all things being equal, be resting on something that gives the stability to allow it to do that. And this activity itself is often the thing that's giving the stability to the next layer up, and so on, and so on, and so on, and so on. So it's one of the mechanisms by which natural systems scale. Hello? Take a cup of tea while I'm waiting for the machine to catch up. Go again. There we go. So there's a word for this idea, coming back to the graph of the blood sugar. Homeostasis. I find that interesting. All this, however long I've been speaking up until now, to describe for me this tremendous beauty of the complexity and the paradox, we could summarize with this graph and this one word. And what's the word they choose? Homeostasis, the word that emphasizes things staying the same. There's that noun again, and the static thinking. Why didn't they call it homeodynamics? This looks like some kind of dynamic aspect to me. This is the interesting bit, and yet the word focuses on this line in the middle. Interesting. Noun and verb. What do lights do? The answer is not. They light. What do irons do? They iron. Certainly in English, there's this correspondence between nouns and verbs. And when Mr. Hoover invents a machine for sucking dirt off the carpet, quite clearly he's not going to sell very many if he calls it the machine for sucking dirt off the carpet. Not very good marketing. And so almost by itself, it becomes a Hoover. The Hoover hoovers. Noun-verb correspondence. Very strong in the way we think and use language. But again, it's subtle because language changes. We change language and the language changes us. There's that duality again, to paraphrase a quote from Churchill. What does this word mean? And again, the answer is not equal rights for tests. The answer is it's changed. And for me personally, the word, when I was younger, had a very strong connotation of a noun. I would think of a proof, for example, in the mathematical sense as being the mathematical proof, the finished proof. Yeah? But there's also the aspect of proving something. And if you look at your history, you study your history, and if you look at online dictionaries for certain periods of time, you can see interesting trends. The word proof, for example, has changed over time. It used to be a verb, and we have echoes of that still in the English language, for example, with the idea of a proving ground, which is less common than it used to be. What is a proving ground? It was literally a piece of ground, an area where merchants would sell spirits. Because if you think about it, in the Middle Ages, for example, if I say I'm selling some vodka or gin or some spirit, and I say it's got this level of percentage alcohol in it, how the heck do you know? I could be watering it down. I probably am if I've got my wits about me because I'm trying to make more money, right? Yeah? But you are obviously in this game as well. There's a duality going on here. You're not wanting to pay for something unless it's got the right amount of spirits. So between us, or mostly because of you, we come up with this plan. There is literally an area, a proving ground, where there's a known experiment we can perform. We put a small amount of gunpowder with a small amount of the spirit, and if the spirit has the sufficiently claimed level of alcohol, it's not enough water to water it down, and you can light the gunpowder and it goes off. It was literally a proving ground. It was an experiment that could fail or pass. And we still have echoes of that slightly with this really quirky odd system of the measurement of the amount of alcohol inside alcoholic drinks. I'm sure Kevlin would have something to say about this. Notice there's not one singleton. So what I'd like to do to close off this first half of the talk is to introduce this idea of testing and coding, to come back to the title of the talk, opposing each other in a stable, co-evolving system. And I really mean that. And I want you to think about that, coming back, for example, to the glucose cycle. Could you imagine in some bizarre world where the top cycle of the insulin was more important than the bottom cycle of the glucagon? It doesn't make sense. That's crazy thinking, okay? You can't say this is more important than that. The two halves of the same thing. That's the way I'd like to think about. I'm trying to think about, and I'm introducing the idea of thinking about coding and tests. The tests are as important as the code when you start to think of them in this more dynamic, richer way as a co-evolving system. And that's what I've been doing for several years, many years now, in the open source project that I started called CyberDojo, which I'll talk about a little bit for some examples as we go through. Feel my voice going again. Did you see the graphics in the background, by the way? I bet you didn't know that in the 1920s, when the women's suffragette movement was going on, there was also a much lesser known movement where women actually demanded more votes for testing. Not many people know that. So, as I promised, here's the second half of the talk, which considers 4 very simple questions. Here's the first question. What is the coverage of a function? For example, simple branch coverage. So I'm sure you understand what coverage is, but for reasons you'll see shortly, we need to be very, very clear about this. Supposing this is the function we're talking about, and here are the tests that are testing the function, just to give some context to running this, and this particular function has 7 lines, 7 statements, you see, yeah? And we'd like to know which of these 7 statements are actually covered, which are necessary, get some measure of the coverage of what this function's doing, and how good is it? Make sense? Yeah? So supposing we do buy some instrumenting tool, and we actually don't just run this function when it's being poked by the tests, we actually run an instrumented, it's an instrumented version of the function, which allows the function to do what it does, but it also gathers off to the side information about which of the statements have been covered. And 6 of them are covered, but 1 of them is not covered. That's what that graphic means. Nothing more than that, right? Happy with that? Any questions about that so far? No? Good. So supposing we do this and we look at the coverage in some nice HTML web browser, and this line here, we think about it and we realize this statement can never, ever be covered. Perhaps it's inside an else. And we realize that our thinking was kind of off when we wrote that code, or someone else's thinking was off when they wrote that code, right? And there's no possible way that the statement inside that else can be run. In other words, we found a mechanism to find dead code. If we're really, really confident that this line, even beyond the context of these 3 test functions, can never, ever do anything useful, we're happy to delete it. But we have to be confident about that. And if we are confident about it, we can delete it, and then bingo, we've got 6 out of 6. We're on 100% coverage with this test function. Which is all, I'm sure, stuff you know. Come on. But the point really is that you've got a mechanism for detecting dead code, for seeing dead code, which is really important. I didn't understand or appreciate how important it was until, like I said, umpteen years ago, when I started doing my CyberDojo project, I started to really look at these kind of things. Turns out dead code is really important. So there was a company called Night Trading, which I first learned about from Kevlin when he was doing a talk right here in ACCU several years ago. And they had a trading system, an automated trading system written in C++. And they had dead code in there, but they never bothered to look for the dead code and remove it. They figured it don't matter, it's just dead code. Why waste our time removing the dead code? Let's focus on the code that's running, that's doing the automated trading. Let's make more money quicker, right? But it was written in C++. And C++ has this odd thing that when you do something that's undefined, you don't know what happens. That's kind of what undefined means. And sure enough, because it's, I would claim, virtually impossible to write C++ that doesn't have some level of undefined behavior, it's at least very, very hard in my experience. On the 2nd of August in 2012, program counter jumped into a line of code that did exhibit undefined behavior. At that particular moment, that particular manifestation of that undefined behavior was to jump the program counter, guess where? Not equal rights for tests. Into the dead code. What was this system doing? Automated trading. And it did carry on doing automated trading in this dead code that had never been run, let alone tested, for years. And it was fast, it was C++. So it could make you a lot of money quickly if it was going well, but it could lose you a lot of money if it doesn't go well. Often people don't appreciate that duality again, right? And sure enough, they lost over $450 million in just a few hours, and they no longer exist. So dead code really matters. What am I thinking of? Hey! What's missing here? For me, it's not obvious, and I'm kind of encouraged that no one is not giving me the answer, because it wasn't obvious to me, and it was a leap of faith to try this stuff. We've got a mechanism here to instrument a function to allow us to see what kind of coverage we get when that function runs, and we just went through that, and here's the lines of code, and one of them's not covered. And we think, brilliant, wow, that was fantastic. We found a way of finding the dead code, giving us confidence of removing it. Equal rights for tests, though, right? Why don't I at least think about the idea of instrumenting the tests? They're functions too. Now, at this point, I usually pause because people's brains start to sort of go on fire. All kinds of ideas are probably going through your head, like they did for me, thinking, well, this is pointless. It's utterly pointless because this function here is an actual function, to use a pejorative term. There's some kind of complexity in here. If statements, for loops, whatever it might be, we can sort of imagine that we really do gain useful information here from covering it. But what are tests? They're just linear. Do this, do this, do this, do this, do this, do this. There's no ifs in the test, at least a good, well-written test in general, right? So if you do put instrumentation on these tests, and you adopt this idea, at least thinking about equal rights for tests, what's going to happen? And to be clear, let's not go fast because people's brains are still probably frying slightly. Forget this function. Remove that function from your brain. We're not talking about the function under test. We've already talked about that. What we're talking about is these functions. We're instrumenting those functions, those test functions. We want to see if they all run to completion, or if any of them have missing statements, etc., right? So here's the function, we're ignoring that. Here's the test function. It happens to have 5 lines, let's say. What are we going to get in general here when we run this test function? What's the coverage of these going to be? Are they going to be green or red? It should all be green. That's what I thought. Most of the time they are. Again, I emphasize, I've been doing this live on the CyberDojo project that I built, which has got a dozen or so microservices, yeah? And I do instrumentation, and I gather coverage, not just for the code, but for the tests. Often you do get full coverage. But sometimes you don't. For various reasons. Maybe you've got an if in here. Maybe you've just got genuine dead code. A simple statement declaring a variable which turns out not to be used, for example. Maybe these test functions are really quite well crafted and quite well cared for, and there's 3 of them, and they had some commonality which has been refactored into some helper functions. There's 2 helper functions. But it turns out only one of them's called. We used to use both of those helper functions in these 3 tests, but we realized, because we refactored, that we don't actually need the second one, but we forgot about that second one, and the dead code is still there in that second helper function, which no one ever calls. And we didn't know about that before, but now we're starting to instrument with coverage the actual test code as well. Now we start to see how often that happens. And I did see how often that happens, yeah? And in, for example, the CyberDojo project called Runner, which is the one that does most of the heavy lifting, which has most of the tests, the largest amount of tests, it was 12%, which is 1 in 8. 1 in 8 commits was removing code that was otherwise not to have been removed because it was dead code. Now, to be fair, it wasn't always dead code on the tests. It was sometimes dead code which was genuine dead code, yeah? But surprisingly often, it was actually dead code in the tests. And the reason I know how many it was because when I found dead code and removed it, I would always put a particular phrase in the git commit message. So I was able to just write a little script to find out how many times it happened across the whole history of the commits and just get some figures back. And it was, in summary, it was much more often than I thought. Much more often than I thought. And the realization for me came that if I find this realization, this dawning that there's all this stuff happening in the test that I wasn't aware of until I started instrumenting it and looking at the coverage. The same thing's happening in the actual code. Unless you look for and measure and find and eliminate dead code, you absolutely are going to have dead code. 12%, 1 in 8 commits was removing what would have otherwise been dead code. For me, my particular style of testing and coding, which is very heavily dominant, relying on refactoring, for example, it was much more than I thought. So I now rely on that as a tool. And I do keep all my tests and all my code at 100%, which some people rail against. Not often, but sometimes you'll see Twitter messages. There was one just a couple of weeks ago, someone saying, trying to get 100% coverage for your tests is a bad idea. There's another Bill Bailey law, right? Well, it's a shame you said that, because if you'd asked the question and you'd said, does anyone have any good reasons why it might be a good idea to look for 100% coverage, I would have quite happily responded to that Twitterer and said, here's a good reason, but they didn't. They just came out with this bland statement saying, it's always a waste of time. Instantly, I'm dismissing it. I'm not interested in that person. They're not going to gain any knowledge from me and me from them. That's the way it goes. That's what I meant at the beginning when I have this more and more pushing away from this idea of always, always, always. Yeah. This happens too. How does this happen? Right, how does that happen? Anyone had this actually happen to them? Come on, yes. It's really common if we're honest. Lots of test frameworks, for example, have some way of annotating or marking or naming the test. So in PyTest, I think it is, you have to prefix it with a test underscore. Is that right? It's certainly still today for modern yeah, it's still true. What happens if you mistype this? It's no longer a test. It won't get run. Will you see that? No. Unless you're aiming for 100% coverage of your tests. Then you'll see it straight away. You were at 100% just a minute ago. You've written a new test, but you mistyped the word test. You run on your test suite, everything passes, but the meta test that says we have to have 100% coverage just drops to 98, 99.6 or whatever, and you think, that's interesting. What happened there? And you look at this and you think, I forgot the test.
But you never write a test that you don't see fail first.
People do. You'd be surprised, Seb.
Yeah, a common thing I do with this is I will clone and modify a test.
Right.
A similar test. And the test has the same name.
Yes.
And in a language like Python, it just overwrites the previous test.
Absolutely. I'm sure we could, I mean, maybe we will, when I finish the talk, have time to talk about these kind of experiences, because I'd love to gather them together. In short, this kind of stuff is much more common than you think it is. Unless you measure it and find it, you won't know. I didn't know. I was surprised, right? But now it's easy to see. So in summary, for me, 100% coverage is not useful because it gives you 100% coverage. No, that's static thinking. It's dynamic thinking. It's useful for me because it tells me when I haven't got 100%. I've momentarily dropped from 100%. And then I can find out why. And if you're just doing this on a regular basis, it's trivial most of the time, almost all the time, to just get back to 100%. Which is useful because you want to rely on that the next time. Yeah? You have a motivation to get yourself back to 100%, not just for its own sake. So summarizing that, full coverage for me is important mostly so I can see when I don't have it. Unless I detect and delete dead code, it will accumulate in your code base. You can be certain. Question 2, what is the complexity of a function? You get the job. So again, I'm not going to actually show code. We're going to just graphically illustrate this. Here's our original f function that we were testing earlier, if you remember. And to depict that there's 3 possible flows of control through this function, technically, I think it's called its cyclomatic complexity, we just put a number 3 here with 3 arrows going through it. That's all we need to see in terms of the picture. One, two, three. Yeah, you've got to remember this. If you don't say it, you won't remember it. So again, if we're thinking about the complexity of a function as measured by some measure such as the cyclomatic complexity, and we're doing that for the functions, the quote actual code, again to use that pejorative term, why not at least consider the idea of doing the same thing for the tests? Equal rights for tests. So supposing we do that, which I do on CyberDojo, and I have done for many years. And here's one of the 3 earlier functions that we saw that were the test functions. You remember they were called test F1, test F2, with test F3. We'll come back to the names of these tests shortly. And they're testing this same function here with a complexity of 3. 5 different flows of control through this. Can you see a problem? Brilliant. This is the higher this number gets, the trickier it is to keep in your brain. In other words, the more likely there is to be a bug. Simple as that. Endless studies have shown that. Yeah? And it doesn't have to be very high for the McCabe cyclomatic complexity. What are tests trying to do? They're trying to give us some confidence that the code is correct, for some definition of correct. So what we've ended up with the situation is we've got less confidence that the tests are correct than the thing they're testing. So again, in terms of the dependency, we've got the measure going in the wrong direction. Just like we talked about for stability and change, you don't want to be something that's changing if you're depending on something that's changing faster than you. It kind of almost doesn't make sense. You can't really depend on something that's changing faster than you, because if you depend on it, you're probably changing at least as fast as it's changing, right? Now, the way not to solve this problem is to go over here and start writing some meta-tests over here that poke those tests. And these meta-tests have got a complexity of 22. Right? Right. The problem is we've got this, as I say, in the wrong direction. What we need is the sergeant operator. If you haven't come across this before, this is the much, much, much less than operator. Right? Which is what we're depicting here. What does this one line represent in a test? What we want as the best case scenario in terms of this measure. The test does not have multiple paths through it. There are no ifs in it. If we did have an if, we split it into two separate tests. One test asserting one thing, the other test asserting something else. It's specific. It does one thing. And hence, we do have the much less than operator. We can be confident that this test individually is more correct than this. And the combination of bunches of tests that each are very specific collectively give us the confidence, which we hope is enough confidence to ship the thing. They are specific. That's an interesting word again. What's the first 8 letters of the word specification? The answer is not equal rights for tests. Specific. Yeah? Well, over and over, once you get more and more experience developing software, at least I do, the same things come around again, just with different names and different understanding and different nuances, but it gives you a deeper, richer understanding. Words matter. Third question of the 4 questions we're going to look at. What does a function do? For example, what does it print? What am I thinking now? 1, 2, 3? Right. I'm not even going to bother thinking about answering this question now for the function itself. Because hopefully you're starting to get the idea. What I'm interested in is the test functions. What do they do? And again, in this particular case, we're thinking about what do they print. Equal rights for tests. Hands up if you ever thought a failing test was passing or vice versa. In other words, you've been fooled. Yeah, everyone. Easy for that to happen for all kinds of reasons. So I claim that a test should do one thing when it fails and something completely different when it passes. And this is quite interesting for a number of reasons. The first one of which is that it's different from most functions. And again, by that, I don't mean test functions. I mean just the functions that are under test. Most actual functions, they're trying to do one thing. That's a mantra we often see. Tests are different, partly because of this reason. We don't want them to always do the same thing. And if we push on that idea, I think it's worth pushing on that idea to get some understanding, some enlightenment. Hello? Seems to be periodically working. In other words, to quote Gregory Bateson, who I mentioned a short while ago, who's one of probably the giant of the systems thinking movement from the 70s. What you want is a difference that makes a difference. I love that phrase. You want a difference between these two outcomes, and you want that difference to be a big difference so it makes a difference. So I say when a test fails, you want helpful diagnostics printed. And when a test passes, you want almost nothing printed. And both of those are worth pushing on because, in my experience, this one is by itself often lacking. Hands up if you've had a test that fails and really there wasn't any diagnostics whatsoever. Right? Why not? Why not? Right. You want equal rights for tests, but the people who were writing the tests didn't treat them as equal first-class citizens. They didn't think about the situation that when they're failing, as they will do at some point in the future, some other poor schmuck's going to see the test fail. They're going to see that diagnostic. So this is one of the reasons, for me, why there's this rule that Seb alluded to earlier. Always run your test and see it fail first. It's not just useful so that you make sure it's actually running and we haven't misspelled the word test. That's kind of probably the most common reason people give for running the test first. But it's also useful so you can actually read the diagnostic, if there is one. Most test frameworks have assertions that come with overloaded variations. If you're doing an assert that this equals this, you've got to provide two arguments in some shape or form. But most of them have the option of providing another argument, right? Which is what? The diagnostic. How often do people always use the diagnostic? Yeah, it's something to think about. Similarly, when a test passes, you want almost nothing printed. That turns out to be surprisingly useful too. So let's see some examples. This is an example of a test that fails, and when it fails, we get output that's fairly clearly trying to indicate something's gone wrong. There's some kind of ASCII coloration on the terminal to make it go red. Yeah, it also prints out information about, in PyTest this is, about the whole, call stack in the actual code base up until the point where the diagnostic failed. This is the actual code in the test. Yeah, on the terminal, printed on the terminal when the test failed. Yeah, pretty good. Come on. This is when they all pass by default in PyTest. I was working with a guy, brilliant young guy in, where the hell was it? I forget where it was, doesn't matter. But what I do remember is the episode when we were pairing together writing some tests. He'd written a lot of tests. There were a lot of tests in the code base in question. And he ran the unit tests, and this started happening. It scrolled by on the screen. Every single unit test as it ran, printed out, you know, the full path up to the name of the file and then the name of the function that was actually the test function, plus some stuff here. They're all green, they're all green, they're all green, they're all green. And then one red one flashed by. A red one flashed by. We saw it go past. And then more green ones, 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 more green ones. This was taking quite a while because one of the slowest things is actually writing stuff to the terminal, right? More green ones, more green ones, more green ones, more green ones, more green ones. You could have almost gone and had a coffee, right? And then finally the tests finished running. It seemed like they were all green except for this one red one that flashed by, and the summer at the end confirmed that. You know, there were 27,492 green ones and one red one. So what did we do? We got the cursor on the left-hand side and we started scrolling back up. Scrolling, 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 ran out of buffer. Couldn't get it. It's gone. Right? Couldn't get it. One story. I'm sure you've got your own stories. It just wastes time. It's not useful. It becomes a crutch that you rely on in some strange way. Chuck it away. Don't do it. If you try a little bit, not too hard in fact, you can get PyTest to just print a single green dot. You really have to have quite a lot of tests to fill up the buffer with that approach. But even that, to me, seems kind of pointless, really. Yeah, because at the end you get a summary, which is the useful part, that tells you how many passed and how many failed. So you only need a little bit of mental buffering up here to know how many you ran last time. You added one test. Have you got one more pass than you had before? That's all you're really doing, and you don't even need to do that if you run the test first, right? So that's number 3. And the fourth one is, what do you name a function? This boy catches on quickly. We'll start by thinking about that question of how do we name a function, and again, to use the pejorative term, an actual function, not the tests that are testing the function. It's difficult. I'm sure we'll all agree. Guy in his keynote this morning, made the joke about naming is hard, and the guy couldn't put a talk together for ACCU because he couldn't think of a name for that idea that he couldn't name, etc., etc. It got very meta and recursive, didn't it? Yeah. Just a few of the many, many considerations about when you're trying to think of a name for a function. Is it a global function or a member function? That turns out to make a difference, because if it's a member function, you're kind of already carrying the context of the state of the instance on which it's called, makes a difference. When you call a function and it returns something, then typically you use that return value, otherwise why are you returning something? So then we start to consider the name of the function not from the definition of the function's point of view, but from the use of that function when it's called, because the expression that calls it, like we said, puts the return value in a variable or something, or uses it in a larger expression. And what you actually want, when people talk about the understandability and the readability of names, isn't the understandability of individual identifiers, because the only time you see an individual identifier is when it's declared, which is once. It's after that you use it that's the interesting part. When do you use an identifier? And the answer is with other operators and other identifiers forming a complex expression, which gives you a value, which might be part of a larger expression. And what you want is that whole expression to be understandable and readable, more than the individual identifier, right? It's not easy, so this is something you might consider. The function itself might have multiple arguments. So again, from the point of view when you're calling that function, you have to provide those arguments. That might also influence your decision about what you name it. Are there side effects when you call the function? Is it a command rather than a query? That also influences your choice of how you name the function. And so we have this tension, this quite awkward tension that we're trying to balance when we are naming names, regular names, ordinary names, in the code itself, not the tests. Because we're trying to balance these competing forces. We want the identifier itself to be small enough that we don't get this explosion in the length of the expressions when we use the identifier in larger and larger and larger expressions. If you've got an individual identifier that's 27 characters long, that makes the expressions it's involved with long, really long, and goes off the end of the page really, really easily, etc., etc. But equally, you don't want it too short to cater for that idea, because then you've only got a very short amount of characters to convey any meaning at all in this poor function that you're trying to name. So that, for me, that's just a little bit of mental unpacking about one of the many reasons why naming just is inherently a hard thing to do. It just is. But that's an ordinary function. 1, 2, 3. Yeah. What does that mean? More than anything, what it means is if you use a technique in the code under test, at least consider the idea of using that technique in the tests themselves, so that you propagate this idea of the code and the tests as equal first-class citizens, where each of them is given as much care and attention as each other. Yeah? Now, to be clear, this can be misunderstood, and this kind of has echoes in the human world. Equal rights means equal opportunities, not necessarily equal outcomes. It's an important point. Because naming a test function is different to naming a regular function, and the reason is because a test function is different. The context is different. You could expect reasonably that the outcome to be different. So let's consider those same questions we considered, some of them at least, when we were thinking about names of a function. Do we call a test function ourselves? Or does the test suite do it for us? Yep. Test suite does it for us. So from that point of view, we don't have to worry about the name of it. Caveat, some rules about it has to start with test underscore or stuff like that, right? Or it has to be something, a function inside a test that's got a base class, etc., right? Mork calling Orson. Any idea what's going on? Come on, you can do it. Hooray. So let's get it back to full screen. Don't know the shortcut. We don't call it. Is there a return type? No, and if there was, what the hell would it mean? Because no one's calling it, right? Who would look at it? Are there any arguments in the test itself? Should be. Caveat, again, sometimes there can be. There's asterisks on all of these because there's always exceptions, right? So, for example, in PyTest, there's a brilliant technique where you can use what's called a fixture to basically pump some pre-canned data in ready for the test without you having to go through the laborious process of instantiating it on the first few lines of the test. It's brilliant. Are there any side effects when you run the test? Shouldn't be if they're well-designed tests. One of the basic caveats of well-designed tests is you can run them in any order, and it doesn't make a difference. Yes. But if you always run them in the same order, you're guaranteed to get a state where it's locking to something that's working. But if you run them in a different order, it won't work. Absolutely guaranteed, okay? If you're not running your tests in a random order, you need to start doing it, I would suggest, or at least think about it. Other reasons as well. So, again, to emphasize the point, the context is different. When we name a function, a regular function, it's difficult. When we're naming a test function, it's kind of the opposite. It's not difficult. You can call it anything you like. It don't make no difference at all to the compiler. It's going to be called anyway, as a little caveat, you prefix it with test underscore. And so we get things like this. Because what often happens in my experience is that this difference that we naturally have with the tests means that the test, there's this almost compulsion, this instinctive reach to try and make the name of the test carry all this weight that we normally carry elsewhere in other syntactic mechanisms, such as the arguments, the return type, etc., which we just said you don't have to worry about. Yeah, and so as we can see over here, if we try and adopt this idea of capturing the whole context, the whole weight of this context, or think about this as a main, every single test is a main, because it doesn't have any arguments. You don't call it. It sounds a lot like main, yeah? You try and embed all that context into the name. It just feels wrong to me. You're trying to do something, and it wasn't designed to do that. The names of tests were not designed to be this long, I think. Yeah, and my gut thinks that too. Now, there are ways you can cheat and try and come around this. For example, Python's such a dynamic language that you can do anything if you try hard enough, right? So technically, it is possible to define a function where you actually split this. And you form a string that's concatenated, and then you use metaprogramming to basically inject the function in with a lambda that forms the body, and that you can chop away all of these, at least in some places, you could chop away some of the underscores and make it something that's readable. In other words, you can end up something a bit more like the commented part here, right? Because this one is split at a point where it doesn't trundle over the right-hand side. Simple as that. Yeah? So I say there's too much context to carry in a single identifier. This feels wrong, it looks wrong, it feels painful. And once I saw that, I started thinking there has to be a better way. And I like to experiment, so I tried something different. Come on. And I started doing this. I literally embrace this idea that you don't have to name the test. All you really want for the test is an identity, so that you know which one it is when you get a diagnostic that it fails. So I've got a little program that I wrote that generates a UID. Yeah, and when I need another test, I either generate a new UID for a new batch of tests, or if I'm in a file, I'll often just use the next one, 4C, 4D, 4E, or maybe space them out a bit if I think I'm going to insert some between. Just that simple idea, that's all it is, yeah? And I carry the context somewhere else. Now, this is going to be difficult or easy depending on lots of factors, not least of which is which language you're using. But with Python, it turns out to be brilliant because what we just had a moment ago, and I emphasized it, were these comments. Yeah? That's what we're doing. This is another way of doing the comment, but it turns out this, for various reasons, this one's better. And this is where we carry the context that previously we were trying to carry up here. And if you remember that earlier printout we had when we saw a failing test, what did it print? In PyTest? If this assert fails, there's an assert just down here. If this assert fails, what was it printing? Everything. The assert with the red stuff comes here, and then you get on the terminal all of this information here. You see this. You see this on the terminal. You haven't lost any information. Yeah? It's just easier to read than trying to scrunch it all into this long name at the top that's easy to scroll off the right-hand side. And it's not just that. Because what I found, I think, in my brain is that when I'm trying to come up with the name of an identifier in the syntax of a language, I know it's, instinctively, I know it's in the syntax of the language. I have to follow the rules of the syntax of the language. There are rules. It tends to, for me at least, I think it constrains my thinking. Plus, you've got this inherent tension that often you write this test and you're trying to get all this information in, and it's just going to trundle off the right-hand side, and you know instinctively it shouldn't be that long, so you're trying to squeeze it into something smaller so that it doesn't trundle off the right-hand side. Oh, it just feels awkward, yeah? It doesn't feel awkward here. You can have this comment as long as you like, and it's a comment. You literally, I think differently. You don't have to consider the rules of the game for the identifiers in terms of the language you're using. This is free-form text. You can just let go and write, prose style, what is it we're doing here, in a manner that's not that different to BDD. But obviously this is not BDD. Now we can go a little bit further with this idea, because once you've got the idea of this test having, each test having a unique ID, it turns out you can, in Python with PyTest, you can create a fixture, which I've imaginatively called T. And T.ID, as the comment here says, because we can very simply use metaprogramming to look at the call stack, find out the ID. This is the same ID as this ID here. Yeah? The test knows its own identity in terms of its UID. This turns out to be really useful. Because, for example, it's one way you can make this test isolated from all other tests, even if it's using a database. Because you can make the database prefixed. Every database name can be prefixed with the ID of the test. And if you're not in the test environment, there is no prefix. Everything runs as it normally runs. Yeah? But more than that, what you're doing is promoting, again, this idea of tests as an equal first-class citizen. Once you have the idea of a test having identity, all kinds of possibilities arise. For example, you're in the actual piece, some actual piece of code, and you'd like to experiment and say, what would happen if I did this? You're thinking about some scenario. Maybe you're writing it as a test. The test has an ID. You can literally write in that piece of code that you're thinking about and experimenting, an if statement that says, if I'm in this test, if the call stack is in this test, do this thing as an experiment, send me some results via HTTP or whatever, and then carry on doing the rest of the stuff. And that can be live in your servers. Really detailed experiments. Yeah? All kinds of things like that start to become possibilities. Come on. So, those are the slides I had prepared. Just a quick recap. The equilibrium law, stable systems tend to oppose their own proper function, right? Didn't understand that. I think I have a better understanding of it these days. Find it very beautiful and paradoxical. Stability is built on activity, which is built on stability, which is built on activity, which is et cetera, et cetera, et cetera. Yeah? I tended to think about things statically, seemed to be the way my brain was naturally wired. feel I have a much richer understanding and experience in life in general when I start to not just think about things dynamically, but again, think about things dynamically and statically in opposition to each other. That's one of the general ideas that I'd really like to promote. So to sort of emphasize that, testing and coding co-evolving, coding and testing co-evolving. Neither of them is more or less important than the other one if we adopt this idea, that they're both equally important in this dynamic view, if you like. Equal rights for tests. Thank you for listening. How are we doing for time? Okay, so what do people think?
So it's interesting. One of the things, so I wrote in Go, and for a while I was using a testing framework, and that hasn't been updated. And I cast around for a new testing framework. And I actually realized idiomatically you shouldn't be using a testing framework in Go. The code should be Go code. So you're not using a specific DSL for tests and equal rights for tests. So your developers can understand what's going on in the tests and in the code.
Yeah, I've only done a smattering of Go, but what I have done kind of echoes that idea. Yeah, it does seem much closer. Yeah. I hadn't thought of that. That's interesting.
It doesn't mean I have ifs, because I don't have certs, but the if is only if this happens, die.
Right. Yes. Yeah. Oh, yeah. Do we want to read out the questions? I'll try and remember to echo the questions. Thanks.
Yeah, so I'm a dyed-in-the-wool Pythonista, so that's absolutely speaking to me. And as we go, my favourite language is absolutely perfect and beautiful for this. Just look at those fixtures and look at the dot strings. It's wonderful. Let's try not to phrase this too. Does it translate equally smoothly into other languages?
So the question was, does this idea of not using long test names and embedding it somewhere else translate equally well into other languages beyond Python, which we looked at here? And I think the answer is almost certainly no. There are going to be languages where it's going to be difficult. But having said that, I was going to say it's going to be difficult, almost impossible in C++, but I take that back rapidly, because if you can't do something in C++, then it basically is impossible, right? Because it can do anything if you try hard enough. But to be honest, for example, in C++, I just don't keep up with C++ anywhere near enough to have knowledge of how you could do it. But my instinct is there would be a way, some way to do it. So if we think about that idea just for a moment, because it's an interesting idea, how would we try and think about it, at least to come up with a plan of attack? Exactly. It's this idea of T here would somehow have to know the context, have the identity, which could be passed to the function itself. But the crucial point for me is this here would become a string that you have to hang off this T object. Right. Right. But again, my instinct is there would be a way to do it if you think about it and try hard enough. It might not be very elegant. It's very elegant in PyTest. But at least some of you are going to hopefully think about it. That's what I really want from today's outcome. Rob?
My question is, can I make a comment?
Yes?
My comment is that I find that the test name, actually, I don't attach much value to the name at all.
Mm.
Because what I do is I get the impression that when I test in the terminal, I tend to run them in the IDE when I'm actually actively developing. And if I get a med test and
Right.
I click it,
Right.
I don't read the name of it, I just click it,
Right.
go to the test, and then straight away I'm reading the code.
Yes.
So
So you sort of come at it from a different perspective, but the different way of to repeat the question, not running the tests not from the terminal, which is correct, I tend to do that, from inside the ID, is yet another good reason why you're not really that worried about the name of the test, because like you said, you can just click on it and bingo, you're in the guts of the thing itself, right?
So going back into GoLand, literally GoLand, the test names, if you name them correctly, so this is the type of the test, the function of the test, then it can actually generate the documentation for you. So it encourages you
Okay. So the comment was in Go land, I think you said.
Well, it's in Go, but Go
In Go.
is built in.
There are built-in mechanisms to sort of do this same kind of thing, and it generates the documentation for you. Brilliant. A question I sort of have is, for you, is, again, to emphasize one of the key things I'd like to emphasize, which I didn't put in the summary, and I should change that, is at least consider the idea that when you're using some kind of tool in the code, coverage, cyclomatic complexity, etc., you at least think about that, using that technique or tool in the tests themselves. Don't necessarily do it, but at least crosses your mind and you think about it. Has anyone ever done something like that now they think about it? And B, if you haven't, can you think of places other than the ones I've shown you where it might be a good idea? Because I'm interested.
So I don't all the time.
Cool.
I've got some things turned off because tests are slightly different.
Right.
So magic numbers and things like that, I don't want to be defining them as constants. Sometimes the magic number is required.
Right.
But yeah, it's there. One of the other things I did, I twitched with a little slide with a typo on it.
Where? Which one? This one?
No, a while back. It's a squiggly green underline.
Oh, I got an underline. Go on. I'm interested. Should we show it? We look at it. Which one is it?
There, fingerprint.
Yes.
Okay. That, for me, needs to be fixed. That needs to be added to your dictionary.
Agreed.
Because otherwise, how do you know if that's a typo?
Yes.
Or,
Yep.
and it doesn't matter if it's a new test, right? Everything needs to be green.
I totally agree. Yep. And normally I do that. I didn't do that on that one, partly because this is old code, which is destined to die anyway, because we're moving it to Go, funnily enough. Any other thoughts about places where you could use this, in general, just at least think about this idea?
John, really nice hearing you talking about using coverage on the test code. I remember the first time I did that, it was by accident. I thought, oh, what an idiot. I was just meant to be measuring the coverage of the real code.
Right.
And I thought, hang on, that's fascinating. And I tried to talk to some colleagues, and they went, oh, weird.
Right. Well, they were partly right. Right.
It doesn't matter if I'm weird, because I went, that's fascinating.
Yeah.
I've not realised that before, and I started doing it deliberately, and I've learned loads from doing it.
I did too, yes.
Really interesting.
Yeah. So the comment was that you accidentally did coverage on the tests. And like me, discovered it really is quite valuable, and it gives you insights that you wouldn't otherwise have got. Leads you to places you otherwise wouldn't have reached.
Do you measure coverage as a specific activity, or do you do it every time? It takes quite a bit longer to calculate coverage.
It does. So again, what I'm talking about specifically, as I did during the talk, was my open source project CyberDojo. That's written in Ruby. I don't know whether that Ruby is faster than Python. I genuinely don't know. But for me, it wasn't a problem in those repos. But again, partly that's probably because they were microservices, and they were, except for runner, they were really quite small. So the test time was maximum a minute. Yeah. So yes, I did do it every time.
So edge case, casting back to my days in Java, where I had an error that could be returned, but actually the only way the error could be returned is if Java had been installed incorrectly.
Right.
So I couldn't get code coverage for that line.
Right.
How do I deal with that?
Right. So the question was, something I'm sure lots of you, if not all of you, have encountered, is you do the coverage stuff like we saw in the slides earlier, and you get to a line in the actual code, not the tests, obviously, and the line might be something like a default in a switch statement. Right, okay? And there's a comment next to the default, and guess what it says? Yeah, this you never get here. But the coverage tool doesn't know that. It just says this line hasn't been reached. So what could we do?
You can check whether it's in a ball.
There's lots of things you can do. I mean, the simplest thing is just to use a pragma to turn off the fact that this one, all test frameworks have a way of saying except this one, right? And I don't mean, by that, I don't mean turn off everywhere the default in a switch statement. I mean, this particular default in this particular switch statement, you just add a pragma saying, ignore the fact this one's not covered, so that the rest of the function can have 100% coverage. So I do that quite often, in particular places. Typically in infrastructure code, I think. I'm just trying to think about that. But I'm wary about doing it. And the other suggestion is you can do something more drastic. Or you could restructure the code. So for example, in Python, where you don't really have a switch statement, in fact, I don't know why I'm saying really, right? You don't have a switch statement. From what I understand, because my knowledge of Python is relatively limited, I've only been doing it about a year, you tend to rewrite those as dictionaries with the key lookup, and the lambda is the lookup from the key. And if there's no key for what you come in with, which would have been the switch that you're switching on, the expression you're switching on, it just blows up. It still blows up. It just doesn't blow up because you reached a default. So you pay as your money, takes your choice. How valuable is it? Depends. Austin.
One thing I have two comments. Comments on the question. One is that you do lose a bit. You do lose specific features by naming your tests. Because PyTest, for example, I can tell PyTest for all tests that contain the word pipeline or something like that. That's one.
Right.
You lost that. So you have lost a small channel of information, which may or may not be important. That's the comment. The other is.
So hang on before we carry on, because my call stack will overflow, right? One of the things we lose with this approach is the ability to basically grep for certain test functions that contain a certain word, which is a useful technique. It might not actually be in the name of the test. It could be somewhere else. There's ways of tagging things, and maybe you'd still have that thinking about it, but you can't do it at least in the name of the test itself, right? Yeah. Okay. Sorry. And the other one?
The other is more. So right now I use this t.id as a key to my database.
Right.
And that's introduced a new connection now between the names of my tests and what I can use as valid keys in that database. If that database changes to the point where I can no longer use those ID, that feels like does that concern you, I guess, is my question.
Absolutely. You have introduced a dependency there in the wrong direction. Normally, the rule of thumb is your tests depend on your code, but not vice versa. But that's sort of not the case anymore, even though the database doesn't know that in this case. So you have to be conservative in this case about the names you choose here. You don't want, I mean, apart from anything else, you couldn't put dots in here or things like that genuinely wouldn't be used, dollars and things that wouldn't be useful, or, sorry, valid in DocumentDB, although it's actually MongoDB in this case, Mongo locally and DocumentDB on the actual server, okay? I'm not too worried about that. We've got bigger problems, to be honest, right? Yeah, but it's a good point, yeah. I mean, apart from anything else, you do have to think about the length of this, because this is a prefix that's being added to all databases. And for example, in, I think both DocumentD and Mongo, the limit, you've only got 64 characters for the name of your database. And you've just used up 8 of them already, which no one else can really see. So yeah, as always, you have introduced, there's a price to pay for these things, right? Yeah. What other tools generally get used in software development, Bo?
Optimizers.
Oh, right.
Optimizing tests. Because if the test isn't run, then you don't get the result. If it takes 5 hours to run, nobody wants to do it.
No. So, I mean, personally, in my context, we are starting to hit that problem in the code base I'm working on at the moment for Merkley. For reasons I won't go into unless you're interested at the bar. But we're basically solving the problem by we're going to pay extra money. So we're using MongoDB as our database. So there's a Docker image we use for that. So there's when you're running a local test, we spin up 3 replicas, or replica set of three nodes, if you like, so that the stuff we do on the database genuinely gets replicated. But that's slow because it's a genuine, if you like, local version of document DB which runs on the server. In other words, it actually writes all the collections and databases and indexes to disk. So we're just going to get out the corporate checkbook and buy that's the word enterprise. I'm so unused to enterprise, I couldn't think of the word, right? We're going to buy the enterprise version, which allows you to run it in memory, which for us is going to be good enough because we'll be able to get off. We're doing a whole bunch of contract checking as we migrate from one system to another system. We're migrating from something that wasn't a database to a database. Let's just leave it at that. Which means everything takes a long time because you've got to do everything twice. Everything is literally running twice. Yeah.
So something you've not mentioned explicitly, I'm assuming it's right, but you should be doing code reviews on your tests as well as your code. And if your code has changed, then your test should change. If not, why not? Vice versa, and actually the documentation comment at the top of the code should also be included in that. But all
right.
three should be interchanged, and your code review should include why one hasn't changed.
So you blew my stack. Can you start the question again?
It's not a question, it's nice. So you're asking about what other things
Right.
should be code review.
Right.
Code review should include, you've changed.
Oh, I see. Yes.
Why hasn't the code changed, or vice versa?
Right.
There may be a reason that's
Yes.
but that needs to be a question you're asking.
You're right. So the question is, if you do code reviews for the code, do you do code reviews for the tests? And you probably could call it a test review, right? And I think it's a perfectly good thought to think, which follows the rule of if we do it in the code, should we do it in the test? At least think about it. But for us at Merkley, the answer is no, because we do everything at least in pairs. So there is no after you've written a code review when it's often too late. And certainly it's too late in terms of a meaningful dialogue in the mentor sense that Guy was talking about in his keynote this morning, which I disagreed with quite a bit of. If you also disagreed with some of it, then hang fire and listen to Seb's lightning talk a bit later.
So your answer is yes, you do code review just live.
We do everything we type, whether it's code or tests, we do it, at least two of us, and so everything is reviewed as you do it. We don't do it afterwards because, I mean, people have done studies, psychological studies, looking at how quickly after an event happens, is it a good idea to actually rectify that, as it were, to use a pejorative term again. And it's not very long. The time after the thing happens drops off a cliff quite quickly in terms of taking remedial action. Yeah? Jerry Weinberg wrote about this. He calls it triggering. If you want to trigger yourself into a new behavior, and you've got some mechanism whereby if the thing you're doing that you want to stop doing, if you do it now, and then an hour later you get a trigger, it's not going to work, okay? An hour is just way too long, right? But if it happens instantly, as you do it because you're working together, it's just much, much more likely to actually be something that has an effect, a generative effect, and actually changes people's behavior. That's my experience. It reminds me of one of the questions someone had at Guy's keynote this morning, when they said, what happens if you've got someone, and more or less I think the question was, and they keep not doing the thing you're asking them to do? Yeah? Well, I think you've set the damn system up wrong, right? Just change the way you do it so that it gets the right outcome naturally, right? Seems a better way of doing it if you can do it. But again, it's easy for me to say that because we're a relatively small company. Once you get to a certain size, there are scaling factors that kick in that are just very, very hard to combat. But good point. Any other ones, or how are we doing for time? Are we over time? How are we doing? 5 minutes.
So, other tooling that's used is various forms of sanitizer, both static and dynamic.
Right. Like linters, for example.
Linters, Valgrind.
Right. Yeah, that's interesting.
Who doesn't lint their test code?
The question was who doesn't lint their and generally there was a comment about static and dynamic analyzers as being tools that might be usefully applied to the tests. Yeah, it sort of, for some reason, it makes me think of mutation testing. Don't know why it popped into my head. It's kind of the evolutionary aspect of it again, I suspect, something like that. And then Dom said something else. What was that? Just to repeat back.
Who doesn't lint? I mean, as a question,
Yeah, who doesn't lint?
who doesn't lint their test code?
It's not common, I don't think. Maybe you should say who does lint their test code. Right. Excellent.
Unused variables.
Right.
Just coming out straight away.
Right. Yep. Yeah. I must confess we don't use linters on our Python code, be it code or test code, but that's partly because we're a startup and we're quite young. We haven't been using Python that long because originally it was. You don't want to know. That was a different story. You don't want to know. Right. Yeah. Yes, to some degree, we do use the stuff that's built in, but as we just saw, when we had the little underlining, we're not quite as good as we should be. But, we do plan to do that. It's just we're trying to get over this big hurdle of migrating onto a proper database. Yeah. Okay, thanks for your questions and your feedback. Hope you enjoyed it, and I'll see you around.